So here is the finished device and GUI for the DC motor control assignment, lesson 116. As you can see, there's no wires connected to the Pico or the breadboard. I'm going to turn the breadboard on. You'll see the LED blink once quickly just to show that it became active, and then once it's connected to Wi-Fi, it'll blink 3 times fast to show you that it's connected. If for some reason it doesn't connect, we'll get 2-second blinks indefinitely. So we'll do that. See the quick blink? It'll give a little while it's connecting to Wi-Fi, and there you go. So it's connected to Wi-Fi. So now here's the dashboard, a forward button, a reverse button, and a stop button, and then sliders. The sliders go from 20 to 100. Right now the forward speed is 0, but they're set to go to 50 when they go on. So I'll click the forward button. You'll see the fan went forward, and now it says the forward speed is 50. If I wanted to switch to reverse, I could either click the reverse button, and you'll see it paused for 1/4 of a second and changed, and that's on at 50. If I wanted to go back to forward, I could click the button again, or I could just click on the slider. So I'll click here, and you see it jumps to exactly where I clicked. I can also grab the slider and move it. I can do the same thing down here, reverse. It stopped and reversed. And then the stop button clearly stops it. And then if I wanted to start, I could start in reverse by either clicking on the speed of the slider I wanted or clicking the button. So if I click there, it jumps to that speed. And like I said, I can also grab the button and slide it to go to full speed. Or I can just click down here to go to 20%. And then I will stop because I'm probably soon going to run out of my battery juice because it takes a lot to run this motor. So now I'm going to show you the 2 programs for lesson 116's assignment, controlling a DC motor remotely with the Pico W as the server that actually controls the motor, and then a PyQt graphical user interface that you click on to do it. So this is the Pico's program. Import the necessary libraries. I set up the onboard LED. As you'll see in the video of the demonstration of how it works. It blinks once when it turns on right here. It's just to show that the Pico's active, and then we set up everything and connect to the wide area net or the Wi-Fi. And then this is my logic for waiting for it to connect, and then after it gets through that logic, if it's connected, it just breaks right out of it. I don't have to wait the whole 20 countdown to 20. If it's connected, it goes into here, and the onboard LED will blink 3 times fast, relatively quickly. If it's not connected, it'll go into here, and the onboard LED will blink really slowly, pretty much indefinitely until you turn it off or reboot it. Set up the socket, and then here you just wait for the request to come in, decode the request, and then split it into a direction and a speed based on a comma, which is how I formatted the request to come. And then if the direction is forward, I'll check to see if the forward PWM is on. If it's on, then obviously this won't be true. If it is 0, then I'm going to set the reverse PWM to 0, because either that means it was either off completely, the motor was either off completely, or it was in reverse, and I want to make sure to set the reverse off before turning the forward on. And then coming down here, this is redundant, I know, but I just set the reverse PWM to 0 just to be sure, and then get the integer of the speed variable, which came in as a string. Do the calculation to convert that to the PWM value I need, and then take that integer and apply that to the forward motor. Send the response that says motor set to forward at a speed of, with whatever the speed is, and then that's it. If it's R, it's a very similar logic, and then if it's not F, because if it was F, then continue would send me back to the top of the while true loop. If it's R, when we get to the bottom of that, continue will send me back to the while true loop. So if it's not F or R, the only other thing that I'll be sending when you see the other program is an O, and then this would turn everything off and respond motor set to off. So this is the program for the PyQt widget or graphical user interface. Import the necessary libraries, set up the client socket with the server address, and then I kind of went down a rabbit hole, did way more than I needed to actually complete the assignment. But when I was searching for how to do something with the PyQt, it came up and recommended that I build the whole widget in a class. So I dug into that a little bit. And then I also wanted the sliders to be able to be grabbed and slid, but I wanted you to be able to just click on the slider and it immediately go to whatever area you clicked on. So this class does that. It takes the mouse press event. If it's a left button, it calculates the value of the position based on the minimum and maximum and where the event was clicked, and then sets the value. If it's on any other event, it just ignores it as far as this is concerned. And then here's the class for the DC motor control. I set the main label for the window, set the style sheet for that main label, create the forward slider and the reverse slider, and you'll see they're just both jump sliders, which takes it back up to here. Set the range for the forward slider and the initial value, same for the reverse slider. Set a minimum width, a minimum height, and then a style sheet for the forward, and then to do the exact same thing for the reverse. Create the labels, create the label style sheets, the forward button style sheets, reverse button style sheet, stop button, and the stop button style sheet. To define what happens when each thing is clicked. So if a forward slider, the value change, we're going to go to the forward handler. If the reverse slider, the value change, we're going to go to the reverse handler. If the forward button's clicked, we'll go to the forward handler. If the reverse button's clicked, we'll go to the reverse handler. And if the stop button's clicked, we have a stop handler. And then do the layout, the QV box layout. And then I did a forward layout, which is also a vertical box, where I add the button, the slider label, and then the slider, and then stretch. And then the reverse layout, I do the exact same thing. And then here's I create all the different layouts. So the main label, add some spacing, the forward layout, add some spacing, the reverse layout, add some spacing. The stop button just goes in right by itself, and then add stretch to bring it out, and then set the layout. And then here are the different methods. So this method is the send request that sends the data to the server. And basically just take the data that it receives from the method that called it and sends it basically to the server in a try. And then there's a socket timeout and then accept as E. So that way, if we don't get a response, it doesn't hang indefinitely. The forward handler sets the direction as F, gets the speed from the forward slider's value, sets the text of the forward slider's label to whatever the new speed is, and then creates the data string, which is the direction, a comma, and the speed, and sends that request, or calls the send request method, including the data. Reverse handler is exactly the same, except it adds the R as the direction, and then the stop handler just adds the direction of 0. It sends the speed of 0, just so that there's a second data point in that data string that will be sent to the server. And then this is where you get everything. You set the app with the sys.arg, set the window as the DC motor control, set the window title, set the window geometry, and then show the window. This, again, I learned this as I was going. Apparently this keeps this class from running if it's called as an import. It has to be, this name is apparently a background variable for Python that determines if it's main, it's being run here locally other than being imported. I do not believe it's actually needed, but it was recommended. Everything I Googled, it seemed like it was highly recommended. So, like I said, it got much more convoluted, but I learned an awful lot doing it, and it was fun to do.